Okay, the first thing to do here is to check P of 1 at n equal to 1. So anywhere we see n here, we place it with 1. We have 1 squared equal to 1 bracket 1 plus 1, 2, 1 plus 1, all over 6. So we have 1 squared is 1. 1 times 2 is 2, multiplied by 2 times 1 is 2 plus 1, which will give me 3, all over 6. So 1 will be equal to 6 all over 6, which 1 will be equal to 1. So we say that P of 1 is true. So if P of 1 is true, we always assume that P of k is true for some k element of natural number. Okay? What it means is anywhere I see n in the expression, I will call it k. I will have 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared is equal to k bracket k plus 1 bracket 2k plus 1 all over 6. So what we are going to do is, this is the assumption state. We check if P of k plus 1 is also true for some k greater than or equal to 1. What it means is we repeat the assumption state to the left first. 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared. Then anywhere we see n here, we replace it with k plus 1. You have here the n squared, we have k plus 1 all squared. Equal to half n here, we replace it with k plus 1. Half n here, we replace it with k plus 1 plus 1. Then we now have n here, we replace it with 2. Instead of writing n, what we write is k plus 1. Finally plus 1 all over 6. So our aim now is to prove that the left hand side is equivalent or equal to the right hand side. So we'll be having left hand side. Left hand side is 1 squared plus 2 squared plus 3 squared plus dot 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 plus k squared plus k plus 1 all squared. This is the left hand side. We want to check whether it's equal to the right hand side. How are we going to do it? We repeated the assumption earlier on by saying that the assumption is the whole of this. So we are going to replace the left hand side of the assumption with the right hand side, as we earlier used to do in the previous video. So we'll be having here the whole thing from here to here to be equal to k bracket k plus 1 bracket 2k plus 1 all over 6, and we are adding it with k plus 1 all squared. So common thing here is k plus 1. We'll factor it out. We'll be having k plus 1 out here. What will be remaining is k here and 2k plus 1 all over 6 plus what will be remaining. 1k plus 1 is out here. What will be remaining here is k plus 1. Okay? So find the LCM. We have here to be k plus 1. The LCM of 6 and 1 is 6. 6 into 1, 6 into 6 is 1. 1 times this will still give you the same thing. K bracket 2k plus 1 plus 1 into 6 is 6 times this will give me 6 bracket k plus 1. Okay? So we now open the bracket to have k plus 1 here, k plus 1 here into the bracket of 2k plus k will give me 2k squared plus k plus 1 will give me k plus 6 times k is 6k, 6 times 1 will give me 6 all over 6. We have here to be k plus 1 into the bracket of 2k squared plus this plus 6k plus k is 7k plus 6 all over 6. So by quadratic equation, I thought in my previous video, one can identify the factors of the quadratic equation by so many rules which I've taught you in factorization. So what you're now going to do is to, if that will be hard for you, check what we have in our right hand side and place it there. So here will give me k plus 2, which is the factors of this quadratic equation, and 2k plus 3. So if I factorize this quadratic equation, what I will get is k plus 2 and 2k plus 3. So finally, what we'll be concluding with is k plus 1 into the bracket of this is k plus 1 plus 1, and this one is the same thing with 2k plus 2 plus 1, okay, all over 6. So let's conclude the final answer by multiplying the bracket. We have here k plus 1, this one is k plus 1 plus 1, and this one is 2 is common, factor 2 out. Now factor 2 out. We'll be having here remaining to be 2, k plus 1, then plus 1, all over 6, which is the same thing with the right-hand side. Which is the same thing with the right-hand side. And since it's the same, one have to conclude that p of k plus 1 is also true. Hence, p of n is true for all n elements of natural number, and that completes the proof.
I beg, now we don't watch and say like just like comment. I just beg you, comment now. Why you do that? You start. You want to go?